We're talking about a controlled experiment. Because we said that the scientific method, it's just a set of steps to get us somewhere. Okay? Like it's to get us to an answer. But the scientific method is like prayer sometimes. Sometimes you request something in prayer, and sometimes the answer is no. Right? So sometimes when you do the scientific method, sometimes you get an answer of what is not right. But at least now you know that's not right, so you can try something else. All right? Like, for example, if I was trying to get in my door, and I'm trying to break through that window, well, I could break the window, but is there any way I'm going to get through the window? No. So am I going to be successful? No. But yes, you know what I know now? Don't do that. Try to find another way. See what I'm saying? Like, that's sometimes what you learn from the scientific method. So it doesn't always lead you to the promised land, but it actually does sometimes tell you where you're not wanting to go. Okay? But in a controlled experiment, what we want to do here is this. We want to test an idea whereby only one reason, sorry, wrong word, where only one condition can be the cause of the outcome. Okay? In a controlled experiment, I'm testing something, but I want to make sure that the only reason whatever happens is because of the one thing I'm testing. All right? Like, let me pick on Jordan for a second and say, let's say he got a new rifle. He wants to go hunting this weekend. What's the hunting season right now, son? There ain't no hunting season going on right now, so I can't kill a rabbit legally. I'd be in trouble. Can't kill a deer legally. Crap. All right. Well, then guess what? I'm going to go and do it illegal. All right? I'm going to go kill a deer. Jordan gets out there with his new rifle. Sees a deer. Bang. He don't hit the deer. Rifle bad? No. You bad. Oh. Well, maybe the rifle could be bad. But maybe he could be a bad shot, right? So how many conditions are there now that cause the outcome? We know of two at least now, right? So therefore, we can't really now blame the rifle. So that's not a strong experiment. You see what I'm saying? In a strong experiment, there's only one reason for what happened. And that one reason is the one thing we are trying out. Okay? So that's a controlled experiment where we test an idea whereby only one condition causes the outcome for what happens. All right? So for us to understand this, we're going to use a very simple scenario. Okay? I need some room, so that's why I'm erasing even though I had so much room down below. Here is our question. Okay? Can a plant grow in beer? All right? Now, if you know the answer to that question, don't tell me, because I'm going to go home and cry, because that means you drink a lot of beer, that you would actually know this already. Okay? But that's our question. So let's just pretend that we're innocent, all right? And we don't know whether a plant can grow in beer. All right? So if I'm going to do this, I've got to do this in two ways. I got to have two groups. Group A and Group B. Okay? Now, Group A is going to be how we normally do things. Okay? So I'm going to put it here the normal way. So if I wanted to grow a plant the normal way, tell me some things I need. Soil. All right, so hold on. Let me go ahead. Put soil. Okay, what else? Water. Okay. Sun, which really is light, because people grow stuff in their basement without the sun, but they use light. Oh, name what they're growing. Go ahead. What else do we need? It's kind of important. Seeds. We need seeds. And we need something else. All right. Oxygen. Really? We need carbon dioxide. Okay? But that's photosynthesis. Okay? Plants produce oxygen. That's what we breathe. So, like, we need oxygen. Plants produce oxygen, right? So think about it like this, right? Plants, they don't need oxygen. It's a waste for them. That's why they get rid of it. That's why they fart it out. Okay? So imagine, we breathe plant farts. Okay? Which makes more sense, because if you've ever been around guys are stupid. You know, what's that? Oh man, that's bad. Oh, who farted, right? But what do? They keep going, that's horrible, man. Oh man, you nasty, right? But they keep staying there. Why don't you just walk away? Right? But they want to keep staying there and smelling it. Okay, that's how stupid guys can be. But that's the normal way, correct? Like, if we do that and the plant grows, are you going to be surprised? No. So, because this is the normal way, and I'm going to say right here on the side, we learn nothing from here. Because we learn nothing, Group A has a name. It's called the control. That is my control group. All right? All a control group is a experiment where things are done in a normal way, where nothing new is going to occur. Nothing new is going to be learned. So somebody say this, well, then why am I doing it if there's ain't nothing new going to be coming from it? The whole reason we're doing this is because we need it for comparison. Now, you can write this somewhere on the side. You don't have to put it where I put it if you don't have the room. But you better write that where you can see it. Because that right there is the whole point of having a control in a controlled experiment. Because my question is this. If a plant, right, if we water a plant in beer and it grows this much, the question now, remember, this is where it becomes your opinion, right? It's called subjective when it's your opinion, objective when it's not an opinion. Subjective is this. If it grows this much, would you say yes, it can grow in beer? Or would you say no, it can't grow in beer? Some of you would say yes, some of you would say no, right? But now what if I said this? When the plant grows in water, it grows this tall, from here to here. But when it grew in beer, it grew this tall. Would you then say that the plant can grow in beer? Some of you would still say yes. Okay? I'm saying I'm right. I would say it can't. You know what I mean? Like, I would just say it can't because, again, it's not going to really do anything much. Because if it's normal is this, and it's only this, then it's going to be on the low end of the evolutionary chain. Okay? But that's just my opinion. You're entitled to your opinion. But that's why I'm saying, but the only way we knew whether to even have that discussion is based on comparing the new thing to the original. Remember the ladies when I said you were trying on them new jeans? Weren't you, when you saw the mirror, what you saw in the mirror, you were comparing to another image that you had in your mind of another pair of jeans that you do love. So you're comparing. But to have something to compare to, that's your control. Whatever you compare to, that's your control. Everybody got the point of a control group? It's nothing that we do. It's what we go back and compare to. All right? Does anybody have any questions about a control group? Because that means over here, this is where my actual experiment's going on. That's why we call Group B the experimental group. Okay? That's the experimental group. This is where I'm going to try what I'm trying. And by the way, what am I trying? So what is my condition that's going to change? Water is going to change to what? Beer. To beer. So what I'm going to notice now is this, and I'm going to write it side by side. I'm going to have the exact same ingredients, but only one ingredient is going to change. That one ingredient is going to be beer. So that way, in the end, whether this plant grows or not, my goal is for the only reason it to be because of the beer. All right? And I'll show you this to show you to the levels of what it could be to really be scientific, to show you the levels. You know how I would make sure there could only be the beer? You know where I get the soil? I'd get one bag of soil, and I'd split the bag in two. One for this side, one for that side. So that way I can't say, well, I had a bad bag of soil, that's what I meant to say, right, for one, but the good side was on the other one. No, I get it from the same bag. The sunlight, I'll put them in the same sun, right? The seeds, I'll split the bag of seeds and put half of them for that side and half of them that side. So that way it can't be I got a bad batch of seeds. There we go. Got that word to it. So the CO2, I'll put them in the same area so they get the same air. You see what I'm saying? Like, you got to make sure, because if I got one bag of soil for that one, but then another bag of soil for that one, could that influence the outcome? Yes, it could. If I had one seed from one, like let's say these seeds came from Walmart, these seeds came from that agri-supply place, right? Could that affect the outcome? Yes. So I got to make sure everything stays the same except the one thing that I'm going to change. Water, and now I'm going to put beer. Okay? Since this is the item being changed, this has a name. It's called the independent variable. Okay? Because that's the item being changed. So when the girls are trying the new jeans, the jeans were the independent variable. That's the thing they were changing. All right? And then the information from what happens. All right? So what happens? You know what I'm saying? Like, for example, you put on the new jeans, right? Then you looked in the mirror. What you saw was our dependent variable. Okay? So our what happens. So in other words, the first thing is this. I got to make a change. That's my independent. What happens when I make the change? That's my dependent. Okay? For example, you have a fever. I have a fever, I have a fever, I have a fever. So what do? What do most people do? Take some medicine, right? So you say, I'm going to take Tylenol. That's what's changed. So you take Tylenol. What happened after you took the Tylenol? That's your dependent variable. Okay? That's your dependent variable. So in other words, you had a temperature of 103. Got it? You took Tylenol. Tylenol. That's your independent variable. Your fever went to 101. 101, that's your dependent variable. Okay? Tylenol is your independent variable. I might have said that wrong the first time. Okay? Tylenol is your independent variable because that's the item being changed. The 101 degrees, that's your dependent variable. All right? Because 101, I don't know whether that's good or bad, but that's what happened. Now, when you analyze that and you go 101, that's still a fever. Well, then you can say that ain't good. That's not working. But 101, that's your dependent variable. It's just information. Do we got it? All right. So